Welcome everyone, and thank you for attending today's webcast, Leveraging Autodesk Inventor Design Automation for ETO and CTO. Our presenter today is Forrest Judd. He's a consulting services with Hagerman and Company. Before we get started, I want to let you know that you're in listening only mode. If you have questions during the presentation, you can type those into the question panel on the right-hand side of your screen, and they'll be addressed at the end of the presentation. As we close down the session today, you'll be prompted to fill out a short survey, and we ask that you take a few moments to fill that out. And additionally, all registrants will receive a follow-up email containing a link for the recording of this presentation. And with that, I'll hand things over to Forrest.
All right, thanks Ashley, and thanks everyone for attending. As Ashley said, please feel free to type questions into the questions pane if you've got questions as we go. I'll keep an eye on that pane, and if it makes sense to address them in context, I'll do so. Otherwise, I'll answer them at the end, and we should have some time at the end for Q&A as well. So again, today we're going to be discussing Inventor Design Automation. So I thought I would kind of run the gamut of what you can do with Inventor from an automation standpoint. Starting out with an overview of all the different approaches you might take to automating the use of Inventor from the simplest to the most complex. We'll take a look at some examples of what I would call traditional design automation. We'll take a dive into iLogic and some of its capabilities, and then discuss where iLogic sort of reaches its limits and where you might need to start employing direct use of the Inventor API. And then we'll finish up with a pre-made example of a solution that uses both iLogic and an add-in using the API together for like a complete design automation solution. So again, any questions you might have as we go, please feel free to type them into the question pane. So the approaches, at least the way I delineate the approaches to design automation in Inventor and how I break those down, we've got the traditional functionality. We have iLogic, which was added in around maybe 2010, 2011 timeframe. It was available as an add-in for I think a year or two before Autodesk acquired it and integrated it into the product. And then of course the API, which has been around as long as I've been using the software, since 2001, and is pretty stable, but it gives you really fine-grained control over what you do with Inventor from an automation standpoint. So the traditional functionality, I lump into that parameters. iLogic added some additional parameter capability when it came in, but the fundamental capability of parameters, this is just generic parametric design capability of equating parameters using basic equations in the parameter expressions, so that when you change one parameter value, one or more other parameters can update to suit automatically. Of course, iParts and iAssemblies, I've encountered many people over the years that have used iParts. I think fewer people are using iAssemblies. I personally am not a big fan of iParts anymore, especially since the 2010 or 11 timeframe, again, when the Content Center really started to improve. I like the Content Center for standard or slightly standard with slightly different parameter values. I like the Content Center for definition and implementation of those things. And then two things that I think most, in my experience at least, most Inventor users don't take advantage of, iMates and iFeatures. So there's some real benefits to using this traditional sort of automation capability. The first is you don't really need to know how to program. As complicated as it gets is essentially an equation you might write in a parameter. And it also uses standard Inventor functionality, standard parametric design practices, so you can take advantage of just what Inventor natively does without a lot of, I would say, niche education. That said, you still have to know how Inventor works. You essentially going to have to be an expert with Inventor if you're going to use a model that's based on parameters or use something like iParts or iFeatures. You have to be an Inventor user. You can't present, say, a program or a dialog box to someone and have them make some choices and then have a model created or adjusted for them, right? They have to know what they're doing inside Inventor. In addition, iParts and iAssemblies can be somewhat difficult to manage, especially when you're talking about using parameters. You really have to know how the model is supposed to work. You have to know which parameters you can change and maybe what the limits on those parameters happen to be. And so if you didn't design the model, or if you're not intimately familiar with how the model was designed, you can get yourself into trouble. And, you know, iAssemblies aside, you're really limited to, you know, single parts or collections of standard components that you're swapping in and out. You know, there's not not really a nice, easy, straightforward way to say, you know, change the value of a parameter or, you know, turn components on and off based on complex logic. So that's where iLogic would come in. Again, this has been around in the software for a while now. I know we have a lot of customers taking advantage of it. It's incredibly powerful. It's essentially a programming interface that lives mostly inside Inventor documents and that executes inside in the context of an Inventor document. And it's there primarily to add intelligence to the models. It is, I hesitate to call it a separate programming language. It's essentially Visual Basic. It does have what are called snippets to simplify some activities. Essentially, these snippets, they're iLogic functions that you can call that behind the scenes is really talking with the API or calling API calls. But it's a simplified way for people that aren't programmers and aren't comfortable with programming, or people that are programmers and just want a shortcut for driving the model, getting information from the model, right? That's where the snippets come in, and the iLogic functions, which we'll see some examples of here in a little bit, right? But you can go a long way with iLogic. You can capture complex design criteria. The code is typically stored inside the documents themselves, which is great from a distribution standpoint or a management standpoint. The code goes with the file, so the behavior is always there. You don't have external files to manage necessarily, although you can store rules externally if it makes sense. A couple years ago, they introduced the ability to create simple forms for user input, which makes it much more capable from a standpoint of you can have someone who isn't very familiar with how Inventor works, but they could, for example, start a new part, provide some information in a form, and ultimately get a model out that meets their criteria without really knowing how to do anything in Inventor other than start a new file and call up a dialog box. It's a very interactive means of automation. It responds automatically to parameter changes. It can also, the rules can run in response to certain software events, like right before you save a document to make sure something gets updated and captured on disk. When you start a new file, when you close a document, there are a lot of ways you can, execute code very simply in response to software events, which especially if you use, say, Inventor macros with the API to try to respond to events, that's, can be kind of tricky sometimes. But it's not perfect. It does have some limitations. It can't manipulate the user interface, right? So I couldn't, for example, add my own tab with commands. I couldn't add my own environment if I had a very complex, add-in that I wanted to highlight. Here's the feature set available. It's not well suited for very configurable assemblies, which we'll see an example of in a little bit. It's not well suited for creating drawings from scratch. And it does require at least some knowledge of programming. Not a lot, right? But concepts of basic logic constructs, like if-then statements, the idea of code executing in order and all of that, it helps if you have a little bit of knowledge of programming, which, I mean, my experience I went to Purdue, and my experience was I had 2 classes that were required where I learned programming. So, I mean, I think most engineers do have some exposure to programming at some degree, and certainly if you've ever taken a semester-long course in college on, C, C++, Basic, C#, any of that, you would have the fundamental, programming knowledge you needed to make really good use of iLogic. So, but if iLogic isn't enough, you might turn to the API, or the Application Program Interface. So this is by far the most flexible and most powerful means of interacting with Inventor. And essentially, it's just a bunch of functions and properties that you can call in some fashion to interact with Inventor in some way. It could be extracting iProperties, it could be creating parts and assemblies from scratch, it could be creating drawings, a whole host of things. And you can access the API in lots of different ways. It doesn't have to be, a standalone program that you write or an add-in that you write. iLogic is a great window into using the API. You can make API calls from an iLogic rule. And I think if your iLogic rule gets beyond a certain level of complexity, it's almost inevitable that you're eventually going to want to interact with the API directly in some form. Very often, if depending on the complexity of what you need, you might write an add-in that lives inside Inventor. Much of the advanced functionality that Inventor provides out of the box is actually just an add-in. Things like the FEA environment, a lot of the translators are add-ins, and so you can have strong impact on the software and how Inventor works by writing an add-in. And of course, Inventor still does include the ability to create macros. It still has a VBA editor, and we'll see an example of that just as an illustrative purpose of iLogic here in this presentation. And essentially what you're doing is you're driving Inventor with code. So you could even go so far as having a standalone program that would launch Inventor, have it do some things, and the user might not even know that Inventor was running in the background, right? So there are a lot of things you can do with the API if you are comfortable with it, right? So again, it's the most flexible and powerful method of interacting with Inventor. You can customize the UI. You can automate just about everything that a user might do. I won't say it's straightforward, but it's much more realistic to build things from scratch, be it parts or assemblies, create drawings from scratch. You can program in different languages. You could use C#, VB.NET. You could technically use C++ if you wanted to, although these days, personally, I stick with either VB or C#. And you can call it from iLogic rules, which is very powerful. Some downsides, though: creating an add-in, you really have to have significant knowledge of programming, understanding of programming, a separate editor to actually create the add-in. Also, every year when Inventor upgrades, the API could change. There's always changes that are made. It's pretty stable for the most part, but if some new functionality gets added or if there's some fundamental change in functionality, there's going to be a change to the API. They're pretty well documented, but your code may have to be adjusted to suit that. One of the great benefits of iLogic is the iLogic functions abstract away the API calls. And so it's on Autodesk to fix the iLogic functions. And so your iLogic rules tend to be extremely stable if you're sticking with the iLogic functions and the snippets, because Autodesk makes sure that any changes that need to happen because of API changes get made in the iLogic code, and so you don't even have to worry about that. Right. And one of the biggest downsides is if you make a change in the way you're, like if you've written an add-in and you make a change in how it functions, you have to recompile that add-in and distribute that update to users somehow. When you're talking about an Inventor add-in, the files have to live on the local computer, so there's that requirement to distribute everything. Again, with iLogic, one of the huge benefits is it lives in the files themselves, or it could be an external rule in a network location that your files point to. So updates to iLogic rules are typically a lot easier. So now that we've got that basic overview out of the way, our traditional automation types, iLogic and API, that's kind of how I've chosen to break this up. The rest of the presentation is mostly going to be showing you how some of these things work. So we're going to start with some of the traditional automation capabilities, I would call it, starting with parameters. And this is often how I will start like a training class when we're talking about sketching or parameters. One of the great things about Inventor is if you wanted any parametric software, you really should be thinking when you model less about just putting lines down on the screen and more about how what you're drawing or what you're modeling behaves. And appropriately naming parameters is a big part of that. One of the great things about Inventor is that you can name parameters when you specify their value. So I can say width equals 4 in that case. And then if I want to add a second parameter, maybe this is height, and if the two are related, let's say in this case our design criteria is our height is always equal to our width times 2, like twice the width. So we can write that simple equation in the parameter, right? And now anytime I change the width, the height will always update to suit, right? And we can do the same thing in just about any dialog where you need to specify a parameter, including the names. So if the length is always 4 times the width, we could specify that here as well. And one thing I really like to do if we're talking about creating intelligent parts, that maybe we make a lot of these parts and they're all slightly different, I love the ability to save as a template and have that geometry and behavior baked into a part right from the get-go. Right? So this is now a new copy of that part that I can modify and adjust, and I have access to, the parameters. And, if you've been using Inventor for a while, you've probably already done this sort of thing, right? So that's great. Another thing that you can do in terms of taking advantage of parameters, though, and I'm not sure that a lot of people know you can do this, is you can actually make features that are dependent upon, conditionally suppressed or unsuppressed, depending on the value of a parameter. So this hole, for example, let's say if the length gets below a certain value, the hole needs to go away. Well, before we had iLogic, the only way we could really do that was to conditionally suppress and say, for example, if the length is less than 8, let's say, the hole needs to go away. And so now if our length is 4 times the width, if I change my width to 1.5, the hole goes away. 2.5, the hole comes back, right? So even without any sort of programming knowledge, you can introduce that sort of general behavior to your models in a pretty straightforward fashion. So most features that can be suppressed have the ability to have this conditional suppression, which is pretty cool. So that's just sort of some basic behavior. If you need more advanced behavior in terms of, our components suppressed, maybe we've got certain combinations of values that are valid, that's where an iPart can become very useful. So in this case, I have a post here. It's not, incredibly intelligent, I would say, but maybe we have some options here for the top of the post. It could be a round shape, it could be a hex shape, and then we have a small and large version of each one of those, right? So, what I've created here is an iPart table. If you've never worked with iParts before, it's essentially just a table of all of the parameters and features that might need to be modified in each iteration of the part. And for each row of the table is a different iteration, and you specify what the values should be for each of these features. Now this is what we would call a standard iPart, meaning there is, a finite number of iterations of this. You can also have what are called custom iParts. So maybe if part of this is we want to allow the user to specify a length that could be infinitely variable or variable over a range or with a certain increment, we can do that by specifying a custom parameter column. In this case, we're not going to go to that length. But essentially what this lets me do is give a user of this component 4 options when they place this into an assembly. They could have a hex top or a round top, and it could be small or it could be large. Now, when the user goes to place this into an assembly, what they'll get is the ability to choose. Now, I intentionally set the iPart up this way because I do see this with some frequency when I work with customers that use iParts, but they're maybe not terribly comfortable with them. If you remember the iPart, we really have 4 options, right? We have round top, hex top, small and large versions of each. So 4 choices. But none of the values that I can choose from, because I could pick, part 1, 2, 3, or 4, it's not necessarily clear to me. If I look closely at all these options, then yeah, I could figure out which version of the part I'm placing. But there's a much easier way for the user to choose which version is going to be appropriate to them. That's by specification of a key column. So a key column in an iPart is, this is a column that I want to provide to the user for them to choose which row of the table that they should apply or that they want to use. And so by specifying a key column, it becomes much easier to use this iPart. And I wanted to do this intentionally. If you're using iParts and you find it tedious to pick which version you want from a table, proper application of a key column goes a long way to making an iPart more usable. So the iPart, you can change it pretty easily from the existing component if you need to. This does instantiate an Inventor part file in a subfolder below the parent, and that's where, one of the cons I mentioned of iParts was management of the files. Vault does a pretty good job of managing the files, but you still have, a parent that defines what the children can look like. You have the instantiated children, and these are essentially, if you try to open the component, you're only ever working on the parent. You can't take a standard iPart like this and add an extra hole in here. You can't do that without making a new iteration in the parent, which is kind of a downside. Which is where I really like iLogic for this sort of thing now, or the Content Center. It makes it a lot easier. So another traditional feature would be the idea of iMates. Again, this is a feature that's not used very widely. Essentially, it's a way to automate the assembly of components. So if 2 things go together the same way every time, or if, like in this case, our post, our goal is to put a bunch of like inserts into the hole of this post, then we can use iMates. So this guy has some iMates on it, a bunch of iMates with the same name. But essentially this is half of an assembly constraint with a name. And the way I can take advantage of that is I can place another component in the assembly using iMates, and you'll notice it automatically wants to pop on to the first available mate that it finds. And if I'm placing interactively, I could iterate through the available iMates, or just by clicking, I can add that component, and I can continue adding components at the matching iMates until I'm done. Right? So that's 4 components that I've added. There is a way that you can generate them all at once, but in this case, maybe the bottom row of pegs needs to be one shape. Maybe the rest of them needs to be slightly different. So I could, in this case, place at all matching iMates. And so just like that, I've built an assembly of all of these pieces. This also makes it very easy to replace components. So I could replace all of these with a slightly different version. And because it's using iMates, even if the 2 models were generated completely independently, the iMates will match up again. And so it also makes it very easy to replace components. And the last bit of traditional automation I want to cover is the idea of iFeatures. Now, iFeatures are essentially ways that you can add simple features, complex features to models based on a few simple inputs. Right? So I've created an iFeature that's essentially a standoff. There's a ring in there, there's a hole pattern. So there's several features involved in this. But if I want to make use of it, all I need to do is specify a circle for like a central, like a coincident constraint, and a plane to put it on. But then I can also specify some of these parameters. And you can see I can actually adjust the size. Now, this one is maybe not terribly well designed. It can kind of get, there we go. So I was able to pretty significantly change this feature based on the input parameters. And that solid geometry in this part, it lives as a single iFeature like so. And there is a sketch that you could go and manipulate to some degree, like I can manipulate the base sketch, but everything else is baked in. So this is a great way if you have standard features that you add to components all of the time for whatever purpose. You can extract those features and reuse them very quickly on models with just a couple of clicks. Right, so again, that's what I would call the traditional automation approaches: iParts, iFeatures, iMates, parameters. And I know a lot of people have been using those things for years. I've been a fan of parameter-driven design and using parameters wisely for a long time. But I know I've worked with customers in the past where I've set up some pretty intelligent models for them with parameters, but they also became pretty hard to use because you had to know how all the parameters interacted and what parameters to modify to get the behavior you wanted. And so, especially if you didn't come up with the model, it can be pretty hard to use. So that's where iLogic, has just been a huge benefit to the software. It can do just a broad range of things, right? I think one of the first things that people use iLogic for, especially if they don't have a lot of need for customizable parts or if they're not very comfortable with programming, it's very easy to use iLogic to manipulate properties. So be it you've got some properties that are maybe a combination of parameter values. If you need to make sure that users provide certain properties and you're not using something like the Vault Data Standard, you want to make sure that iProperties get populated appropriately. It's a really great tool for that. Of course, manipulating components themselves, complex rules, driving the size or configuration of a part. iLogic is just a perfect fit for that. Automating configurable assemblies to some degree. If the assemblies start to get too complex, that becomes a problem. We'll talk about that in a little bit. But another one I'm seeing more and more lately is automated generation of what I call neutral files, files that you need to share with others. A PDF of your drawing, a step file or an SAT file of a model, even an exported DWG of an Inventor IDW. You can set up iLogic to create those files automatically, say right before or right after you save a document, to make sure that the consumable version of the file, like the PDF of a drawing you're putting out, always matches what the Inventor drawing shows. And we'll see an example of that. And it really is very easy to use. There's a great code editor built into Inventor. It provides code formatting. There's some wizards for more complex things. Easy access to things like parameters and features and assembly occurrences. There's a whole host of snippets that combine both mostly iLogic functions, but also some API calls to help get you started with, I want to change a parameter value or I want to change a property value. You can use a snippet to see what the format and the syntax should be. A really great, easy way to interact with events. So the first time you create a file or open a file or save a file, you can run some code in response to that. Also, code can run, and by default does run automatically anytime a parameter in the rule changes, right? So that makes sure your rules always execute and update accordingly. And then the ability to create forms greatly simplifies when you have to ask whoever's using your iLogic rules for some sort of information. So let's take a look at iLogic now. We're going to start in the context of that first component that I created, this little block with a hole in it. Yeah, this guy here. Right, so if you remember, we'd set this up. It's a very basic, arrangement here. If the width is below a certain value, or the length is below a certain value, sorry, if the length is below, let's just see what it was. If the length was less than 8, then that hole should be suppressed. Otherwise, it should be there. And that's great if that's the only thing about this hole that needs to change. But let's say that actually what we're shooting for, if the length is less than 4, then we don't need the hole there. But if it's between 4 and 8, we need the hole there of a certain size. But then if it gets beyond a certain length, we need to use a larger fastener, and so the hole needs to get bigger. Well, you might be able to craft a function for the diameter of the hole to meet those criteria, but I personally don't want to have to think about that. And if you get more, if you add a third criteria, it becomes even more difficult. We can't do any sort of if-then inside a parameter equation. So that leaves iLogic. So in this part, I'm going to create a new iLogic rule. We're going to call this hole size, hole manipulation. So this is the iLogic code editor. And you'll see we've got snippets on the right, which gives us access to various things within the software, parameters, features, properties, lots of different things. We have access to our parameters here at the top, our features, and then here's our code editor, which will format the code, based on what we type in. It's got some shortcuts for like, indent, for comment and uncomment, some common logic operators, math operators, certain keywords for certain, logical constructs. But this is going to be a pretty straightforward case. right? So I want to do, in this case, if our length is less than or equal to 4, then something needs to happen, and that something is the hole needs to be suppressed. And so I can capture what is right now the current state of the hole, and this is going to pull everything off of the hole. It's suppression status, but also any of the parameters that might drive it, which is pretty nice. In this case, we don't need those. All we need to do is, if the length is less than 4, then the feature is not active, right? So you notice I really haven't typed anything in here yet other than the number 4. So I was able to pick, everything I needed from this interface. Now, nothing prevents you from typing, right? And I code a lot, so I'm more inclined to type. We can say if the length is less than or equal to 8, then we need the feature to be active, right? And you can, just like any coded editor, you can copy and paste, you can write these equations, but also the diameter of the hole needs to be a certain value, right? And we'll say it needs to be 0.5. And finally, if neither of those criteria is met, then we still want it to be active, right? But the diameter maybe needs to be 1. So with just a few lines of code, now we have that behavior. If the length is less than 4, the hole goes away. If it's between 4 and 8, it's there at a certain diameter, and if it's greater than 8, then the hole gets bigger. So now all I need to do is change these values, right? So at a width of 2, length of 8, notice we have a hole that's relatively small. I change to a little bit bigger, the hole gets bigger because our length is now above 8. But if our length drops below 8, the hole goes away. Right? So pretty straightforward, and that's relatively complex behavior from a traditional Inventor model standpoint. Right? So that was pretty easy. Another really common use of iLogic would be manipulation of properties. So let's say that not only do we want to have this behavior, but we also want to capture maybe the stock size of this. And I'm just going to, in the interest of time, I'm going to drop this into the part number. I can set the value of any of our properties. Well, we should just be able to change that to stock number. In this way, a snippet lets us get to our project properties, the stock number property. And I can set that equal to some concatenation of our model parameters, our length, our width, and our height, right? And there are other really useful snippets here. One of them is the ability to round a value to a fraction. So if I want to report this stock size as, rounded up to the nearest eighth, and I want to show it fractional, I can do that just by using one of these snippets, right? And we're going to round it to, in this case, we're going to round our width to the nearest eighth up, and it's going to be displayed as a fraction. And then if I want to really format this properly, where, you put like width by, height by length or something, I might add in a symbol like so, and then I just need to copy this a couple times to get the whole expression, right? So we have our width, our height, and our length. Oh, I've got a syntax error somewhere. There we go. And what we should see now is our I property, stock number, is set to 1 by 2 by 4, which is boring. Let's change this to something else like 1.1. And what that should have done, since our parameters are in that rule, it should have executed automatically. And now what we should see as our stock number is 1 1/8 by 2 1/4 by 4 1/2. Right? So, and that was pretty straightforward. That only took, literally a few seconds to build a property based on our parameters. So now we have a stock size that we can put on the bill of materials, for example. Now, if you can also set this to run, say, if you want to make sure that the properties rule always runs, like right before you save the document so the changes get captured, you can use the event triggers and say, before the document is saved, make sure and run the properties rule. That way anything gets captured. So, if you're manipulating properties that don't involve parameters for whatever reason, the rule won't run automatically, so you may need to run it in response to a trigger. And a question did come in, is there a way you knew how to fix that error? Is it just experience, or could you tell from the error it gave you? That's a really good question. That's one thing about iLogic that can be a bit of a struggle, is debugging, because it's not like you've got code that's executing where you put in a breakpoint and get a really detailed error necessarily. So the issue I had was, it was just a syntax error. I was missing an ampersand. When I tried to run it, the message I got was end of statement expected. It's not terribly useful. I figured that out based on experience, knowing that I copied in haste some text and pasted it a couple times, and the fact that it said end of statement expected, that told me it was some sort of syntax error. Right? The statement was not well formed, and so that prompted me to go back and look through each part of the statement and notice that, okay, I was not essentially adding, ampersand adds strings together. I was not adding the strings together properly. I was essentially missing a plus sign. Right? So that's how I determined that one. Right, so a couple more examples of iLogic. I have this post that I created. This version of it actually, it's very similar to the I part. The difference is it's being manipulated by an iLogic rule. So that 4-member table that I had for the different options, I essentially replaced that with a few lines of code and some custom parameters. So this is a great feature that iLogic added when it was integrated into software. The ability to, well, one thing for sure with the idea of key parameters, I have all of these model parameters that I don't necessarily need. Certain parameters I do want to keep. I can set those as key parameters and then filter this list and say, show me only the important ones. This is a huge benefit if you're manipulating complex parts. But I also have parameters here that are text parameters. Right? I can add text Boolean parameters, and our text parameters, even our numeric parameters now can also be multi-value. That's one thing I want to add to the idea station is when you've got your list of parameters filtered by key parameters, when you make a new parameter, it's not key by default, and so to see it, you have to turn off the filter and turn it back on. But I can make any of these parameters multi-value, and this makes it very easy for users to take advantage of, or to leverage the idea of logic and say a user can pick between choices, and then your code can make a decision based on those choices. So it becomes very user-friendly, and the end result is that a user can be presented with, reasonable choices. Should the top be round or hex, and should it be large or small? Just about anybody can, make that determination what they need, and they don't have to know what parameters to change. They don't have to know really anything about how the model works, right? And these forms are incredibly easy to create, right? The form editor, essentially, I just drag in whatever parameters I want to be present on the form, and it just builds the form, right? So if I, wanted to, add the post diameter as an option in here, I could do that. And now I could change the post diameter. Now, I don't know if this is going to break my model or not. We'll see. No, not too bad. I think I designed it fairly well. Right. And then one last thing I want to mention about iLogic, because I see this more and more, and I think it's a fantastic use of the capability, is using iLogic to generate neutral files. So I've got a drawing here that's got a pretty simple rule in it all told, and you can even like Google this and there'll be examples on the Inventor forums, but essentially this is a rule that's using the Inventor API and the PDF translator add-in, right? Because if you look at your list of add-ins, there's a whole host of translators. All of these are how we get neutral files, files of different formats out of Inventor or into Inventor. And one of those is PDF, right? And so you can create a rule that essentially, with certain options, right, like print everything as black, remove the line weights, set the resolution, the sheet range, so the way you want the PDF to come out, where it should go, it should have a different name, etc. Like you could incorporate, say, the rev letter from the iProperties into the PDF name, for example. And then, if you ever make a change, let me find a more interesting file here. The PDF as it stands now looks like this, right? So this matches my drawing right now. If I change the drawing and I want to make sure that it gets updated, my rule is set to run right before I save the document. So right before you save it to disk, it would help if I didn't have the PDF open so I could actually overwrite it. Now that has updated the PDF, and now just like that, just by saving the file in Inventor, I have a new PDF. And you could set your code up to write to like even a network folder if you needed to. I also have customers that use this with Vault. You create the PDF the first time, you check it into Vault, attach it to the drawing, and then every time you check out the file, the PDF can come with it. You hit the save button, it updates. When you check the drawing back in, the PDF can go back in with it. So it's a sort of way to semi-automate the creation of a PDF inside Vault for your Inventor files, when you're doing it during check-in, right? So that's a more common use that I see. Right, so I do see another question. Where's the best place to find details about the API? The object browser model only goes into so much depth. That's a really great question, and it's a great segue into the last part of the presentation, which is essentially the API and when to use it, and when iLogic isn't enough. So we're going to get to how you can figure out the API and how to use it here in just a second. So iLogic is very capable. You can do a ton of things with it, right? But it's not complete. It's not perfect, right? The snippets, there's only a very limited. It's a specific implementation of API functionality. It's only a tiny fraction of what you can actually do with the API. iLogic struggles a bit with highly configurable assemblies, which we'll see here in just a second. It's what I call the kitchen sink approach. If you want to build an iLogic assembly that's configurable, you have to put everything but the kitchen sink into that guy. You have to put everything that might need to be there, and then turn off what you don't need for each specific configuration. We'll see an example of that. The iLogic rules are document-centric. You're always executing in the context of a rule, of a document, sorry. With an add-in, if you're using the API, you're essentially executing at the application level, and that gives you lots of freedom to do a lot of different things. There are a limited number of events that your iLogic rules can react to. The iLogic forms are great for simple input. If you need any sort of code behind for error checking for user input, if you want to have a more complex form, you really can't do that. And it's difficult to create iLogic drawings from scratch, right? So I'm going to skip over one example here because we're starting to run out of time. Just quickly, one of the examples, when you access the value of a parameter in iLogic, you're getting the nominal value. If you needed to react to, say, the model value, let's say you're using tolerances, all right, you can't get that without an API call. You can't change the name of a parameter without an API call. You can't toggle whether it's referenced or not. You can't modify its tolerance or its expression, right? So the API gives you a lot of capability that iLogic fundamentally doesn't. Now, because you can access the API from an iLogic rule, you can take advantage of the API calls from within the rule if you need to, but you still need to know about the API and how it works, right? Where iLogic really starts to fall apart, where I see a lot of people really want to use iLogic and it becomes difficult to do so, is with configurable assemblies. It works okay with configurable assemblies. Okay, you have to use a level of detail and component suppression. You have to put everything into the assembly that you might need and then manipulate those things. If you have a large number of components, it becomes difficult to manage. So let's take a quick look at that. I have an example where we've got a configurable assembly. Just to address the question quickly, I am almost entirely self-taught with the Inventor API. Most of what I learned is from the programming help. So if you go to if you expand the help menu here and go to help programming/API help, this is a fantastic resource for learning the API. First of all, you can search on any object like a model parameter, and you can see the model parameter API object. This gives you all of the methods and properties. Often we'll have access to a sample as well. When you click on a sample, most of these are designed to work with VBA because the help is kind of old. But if you slightly tweak the syntax here, like remove the word set from the assignment statements, in most cases, these guys will run inside of an iLogic rule, which is a great way to experiment with the API. So there are just tons of samples. You see the sample programs. There are just many, many, many samples. So this is where I would start if you're trying to learn more about the API. There's also an Inventor customization forum where you can go and ask questions. So I want to quickly show this assembly because this is a pretty simple assembly, 3 components, and the way this assembly works is I'm always going to have 3 parts, and these 3 parts could be either a hexagon, a rectangle, or a cylinder, and they may or may not have holes, and their diameter and length can change. So pretty simple, I think. To pull this off with iLogic, I need to ask the user to specify essentially everything by the shape, right? So for the first shape, what type is it? You know, it's a cylinder and it doesn't have holes and the diameter, you know, is maybe 6. And the second shape, you know, and the third shape, right? And what you'll notice is everything is there. It's just depending on what I've selected, components are turned on or off. So iLogic is not a great way to build an assembly like this, because if we look at the rule, it requires all of this code because everything has to be manipulated for every case. And so every time I want to, let's say I need to go to 4 shapes or 5 shapes, now I've got to manipulate all 5 shapes with my rules. And the rules get very long very fast, right? Which if you don't know much about programming or add-ins or anything like that, you know, at least it will get the job done. You know, but a better implementation might be a custom add-in where, first of all, you can provide a slightly different user experience where it could be an arbitrary number of shapes and they just add to the list of shapes that they want, right? So the first shape is going to be a cylinder, 6-inch diameter, 8-inch length. It's going to have holes. Add it to the list. And that way they can essentially build this up to whatever specification they have, right? And, when you're at this point, eventually, like let's say it's order entry, has a big list of all the shapes to build this up. You could have your add-in program read in a file from like an ERP system or something, so where the user doesn't even have to fill this out. They just say process this file, and it builds everything for them, right? So this is a fundamentally different user experience. And when I press build, it's actually going to, in this case, take copies of parts I've already created, manipulate them with the right values, put them together into an assembly, and constrain them appropriately and stack them all up. So I still end up with an assembly of components that I can manipulate, but it was a much easier experience for the user for sure. And from a coding standpoint, it's pretty straightforward. So, another question came in, what language do I program my add-ins with? I use VB.NET. And see, this is the add-in for this presentation. So with this assembly of the original iLogic assembly had 3 parts to it with 3 options. Well, what if we want to, first of all, if we want to add more parts to it, it becomes very difficult with iLogic very quickly because you have to account for every part and every option. What if I wanted to add a new shape? Well, suddenly now, instead of 3 shapes with 3 possibilities, I have 3 shapes with 4 possibilities, and I have to add a bunch of code to do that. Well, with an add-in, it could be pretty straightforward. I could say, well, I'm going to make a new part to use as the template for my new triangle shape, and I'm going to add some information to the UI to say if the user picks triangle, then use that template file, and then I've got a user interface here where I want to make sure and add that as a choice, but essentially was like 4 or 5 lines of code is going to expand the capability of my add-in tremendously. The downside is I have to rebuild my add-in, and I have to redistribute it to the end users. So that is one of the downsides of using add-ins. But just by making those code tweaks, I think I caught them all, and recompiling, essentially I now have new additional behavior in my add-in for users to take advantage of. And yes, I could have done that with an iLogic rule. It would have taken a whole lot longer to manipulate that rule to add in maybe the ability to do 10 components. And then your iLogic form has 10 tabs in it, and if the user only wants 4, they have to go to 6 more tabs and say, I don't want this part, right? So again, there is work in getting something like this set up, the add-in set up, but once you do your first add-in and you've got some, your UI customized a bit and you're adding commands, it becomes pretty straightforward to add additional ones, and then it's just a matter of knowing the API and what you can do with it. Right, so just like that, now I have the triangle shape implementation. And, it would have taken about 5 minutes tops to add in that additional code. Right, so I think that's essentially it for the presentation. I want to show one more example of sort of a complete solution. And this does take a couple minutes to run because it's doing something fairly complex, but this is a proof of concept I did a couple of summers ago. Essentially what this lets me do is build a curtain wall assembly, an outer frame, and a series of window panes. And it can be a square frame or an angled frame. I think we'll go with an angled frame. We're going to make it, relatively short. That way it runs in a reasonable amount of time. I'm trying to remember, this was a proof of concept, so it's not perfect, but that should get it done. But when I hit the build button here, this is actually going to start building out an assembly for me. And this actually uses iLogic and the API together. So the API with an add-in builds this outer frame. It then drops in some assemblies that use iLogic to configure each individual pane. And the add-in simply manipulates parameters in these assemblies to allow them to update properly. And then eventually it's going to create a drawing. Right. So, and that's, what I want to end on is, using the iLogic functionality and the API in concert, be it inside a rule or with an add-in, right? You can use iLogic to drive component size and shape, use it to control simpler assemblies, use those API calls in iLogic rules when it makes sense to do so, right? But an add-in with the API lets you create new documents very quickly, instantiate new occurrences, create assemblies from scratch and drawings from scratch. It can make it easier to communicate with other business systems because you've got easily got the whole .NET framework at your fingertips, which you technically do in an iLogic rule, but it's more difficult because it's always executing in the context of a part or an assembly or a drawing, right? And then finally, you can use, if you've got an add-in, you can use Windows Forms, to provide a much more rich user experience, right? And so this guy's probably still working in the background here, right? It's just making drawings, but I think it's almost done. There we go. And, well, it's still drawing. So I guess we'll go ahead and, if there are any questions, we've only had a few questions come in. So if there are any other questions about what we've, talked about today, please feel free to type those into the question pane while this finishes building. And while we're waiting, just what this is doing is making a drawing with each unique panel in it, right? So the end result was an assembly with unique panels to meet the requirements, to fill this angled frame. And then the drawing has a bill of materials with everything rolled up and quantified, and then each drawing sheet details either the members of the frame or in this case, the assembly panels. And this is where you get into drawing automation. It always can be a little tricky to automate drawings across a wide range of values. But you can usually, with a little bit of tweaking, get them to work out pretty well. So another question came in. Is there going to be a recording of this we can watch later? Yes, it has been recorded. I believe you'll get an email or some sort of notification with a link to the recording later on. Right, another question. I've heard of using a SQL database to store all of the parameters. Yeah, that's totally valid if you've got complex build requirements where you need to have certain iterations and you need to pull a list of parameters from some spot. A SQL database wouldn't necessarily be a bad approach if you've got one handy. It does complicate things a little bit, having to communicate with SQL Server and have the instance maintained. There are other ways of storing the data if it's not a bunch of it. An XML file would potentially be a pretty good way of doing it. You can parse and interact with an XML file from code pretty well. iLogic also has a bunch of snippets that make it easy to interact with spreadsheets. So I'm not a huge fan of using spreadsheets, but it's an easy way to store data and get at it for sure. Right, so there's a whole bunch of Excel, getting a certain row or a certain cell value out of opening and saving a spreadsheet. So there are lots of ways to manipulate pretty easily. So another question, to add the dimensions to the drawing automatically, did I use iLogic or the API? That was 100% the API. In theory, I could probably get it to work out with an iLogic rule, but essentially when you're adding dimensions via anything, what you have to do is you need to have some sort of reference feature you can always land on. So in the case of one of these frame members, what you'll notice is we open up the model, there's a work plane here and a work plane here and a plane here, and this is even called angled dim to plane to end plane. So this is essentially, these work planes exist so that I can capture them in the drawing view and then use those work planes for the dimensions that I need. because trying to dimension to geometry of a model, possible, but it's tricky, right? So anytime you're dimensioning with the API of any sort, you're going to want work features to land on. And I do want to make sure, because the question was, to add the dimensions, did I use iLogic or the API? When I say API, it's definitely the API in general. It's the means of communicating with Inventor directly, the language that it speaks, for lack of a better term. There are lots of ways you can access the API. You can do it from an iLogic rule. You can do it from an add-in. You can do it from a macro. You can do it from a standalone program. There are certain methods of accessing the API where certain things are easier than others, right? So I can't modify the UI. To modify, like add a tab and commands, that's an API call, but you can't do that from an iLogic rule, right? So you would need to use an add-in to do that. There are lots of things you can do in an iLogic rule that take advantage of the API, though. All right, so we haven't had any questions come in for the last couple of minutes, so I think with that we'll wrap it up. Ashley?
Okay, thanks, Forrest. Yes, this will conclude our broadcast. If you think of additional questions later on, you can simply reply to that confirmation email you received from GoToWebinar, and we can get those to Forrest or the appropriate person. Once again, if you could take a few moments to answer the short survey, we would appreciate it. It will just automatically pop up as we close down the session. Again, you will receive a recording of this presentation probably tomorrow in your email. And that's about it for me. So thanks everyone for attending, and have a great day.